Find the real roots of the equation a raised to power 4 equal to square bracket a minus 1 raised to power 4. Hello everyone, welcome to my maths class. In our class today, we are going to find the roots of this equation. But before we start, kindly like, share, comment, and don't forget to subscribe to this channel to get a regular update of our videos once they are uploaded. Remember, our subscription to this channel is absolutely free. Now let's solve this equation. To solve this equation, we are going to expand this value of these values of a raised to power 4. This will give us a raised to power 4. This will give us a raised to power 4. This will come back to this place to give us minus bracket a minus 1 raised to power 4, and all of this will be equal to 0. Now in this bracket we are going to have a raised to power 4 minus bracket. We'll have the smaller bracket in it minus a minus 1 raised to power square, all raised to power square is equal to 0. And this itself will give us a raised to power square bracket square minus all brackets a minus 1 square all square equal to 0. So from this equation, you come to see that we already have a difference of 2 square, a square and a minus 1 square, while both of them are carrying a square. Now recall the rule in a difference of 2 square that if you have a square minus b square, it will be equal to a plus b and a minus b. So if we apply that into this equation, remember our a in this time is a. Our a is equal to a square and our b is equal to a minus 1 square. So if we apply that here, we're going to have a square, right, plus bracket a minus 1 square, that's on one side, multiplied by a square minus bracket a minus 1 square, that's on the other side. So what we are going to do now is this will be equal to 0. We're going to simplify this. For we to simplify this, we are going to simplify this to become, we're going to expand this to become this. But before we expand this, I want you to note something. We have a raised to power 1 square. If we find the value of a raised to power 1 square, remember it will give us a raised to power 1 and multiply by a minus 1 multiplied by a minus 1. And if we multiply this simple equation, we are going to have a times a to give you a square. This will give you minus a minus a. Minus times minus will give us plus 1. So this will give us a square minus 2a plus 1. So if we apply that here, we're going to have our a square plus bracket a square minus 2a plus 1 multiplied by a square minus bracket a square minus 2a plus 1, and all of these will be equal to what? 0. So what we have to do now is to expand the whole expression. We will expand this whole expression. We are going to have in this other part, we're going to have a square plus times a plus times a square will give us plus a square, plus times minus will give us minus 2a, plus times plus 1 will give us plus 1. That will be on this side. While on this side, we'll have a square minus a square minus times minus will give us plus 2a minus 1 equal to 0. So if we have this, we're going to now simplify further. To simplify further, we collect like terms. This will give us what? 2a square minus 2a plus 1, while this will give us a will cut a, and what we'll have here remaining is 2a minus 1, and all of this will be equal to 0. Now we have come to a point where we have two distinct equations. We have 2a square minus 2a plus 1 equal to 0, and we'll have 2a minus 1 to be equal to 0. From here, we can have 2a to be equal to 1. If we divide both sides by 2, we are going to have this to clear this, and our a will be equal to 1 over 2. So this stands as the first value, the first real value for a. On this other side, we have a quadratic equation. So we are going to solve that quadratic equation quadratically. Solving that quadratic equation quadratically, we'll look for our a, and our a will be equal to minus b plus or minus square root of b square minus 4ab all over 2a. So if we solve that, comparing that with the equation we are given, you'll find out that our a is equal to 2, our b is equal to minus 2, and our c is equal to 1. So we're going to simplify this and then look for other real values of a. A now will now be equal to minus into bracket minus 2 plus or minus square root of minus 2 square minus 2 square, this is 4ac, minus 2 square minus 4 times a multiplied by our c is our a is 2 plus our c multiplied by our c equal to, that is 1, all divided by 2 times a, which is 2. So if we simplify that further, we are going to have a to be equal to minus times plus is minus times minus is plus, plus or minus, we'll have this to give us 4, minus 4 times 2 is 8 times 1, that will give us minus 8 all over 4. So if we simplify this, we're going to have a to be equal to 2 plus or minus square root of 4 minus 8 will give us minus 4 divided by what? By 4. So our a now will be equal to 2 plus or minus square root of, this will give us 4 times minus 1 over 4. Now recall that if we have our square root of I is equal to square root of I square root of minus 1 is equal to I. That's according to complex number. In complex number, square root of minus 1 is equal to I. So from that expression, we'll have our A to be equal to 2 plus or minus square root of what? 4 times I all over 4. So from this expression, we'll find out that will imply that our A will be equal to 2 plus square root of 4, which is equal to 2 I over 4, or we'll have our A to be equal to 2 minus square root of 4 is 2 times I over 4. So if we simplify this, 2 will cut 2 here, 2 here 1, and 2 here will give us 1. So we'll have our A to be equal to 1 plus I all over 2, or we'll have our A, this will give us 2, this will give us 1, this will give us 1. It will be equal to 1 minus I over 2. So having gotten that, the final solutions to this quadratic equation, the final roots to these quadratic equations are A, the first initial root we have is A equal to half. So A will be equal to 1 over 2, or A will be equal to 1 plus I over 2, and A will be equal to 1 minus I over 2. If you enjoyed this class, subscribe to this channel and don't forget to share this video with your friends and colleagues.